So in 8.1, we're going to be dealing with translations. And the very first thing we need to know about are rigid motions. Rigid motions are when an object does not change shape. So we're going to have 3 examples of what some rigid motions are. In section 1, we're dealing with translations. In section 2, we're going to be dealing with something called reflections. In section 3, we're going to be dealing with something called rotations. All 3 of those are rigid motions, just so you know. And that's what we're going to emphasize today. I'm just going to write that down. We're dealing with translations, reflections, and rotations. All 3 of these are examples of rigid motions. All 3 of these, the object doesn't change shape. It still is the same size shape that it was when it started. It just, something happened to it. So what we're going to emphasize in section 1 today is just this one here. In section 2, we're going to deal with this one. In section 3, this is what we're going to deal with. But these are all rigid motions. I want you to know that. So let's go right into what we're talking about today, and that is a translation. A translation, if I were to give you Mr. Promo's definition, it is a slide. Up, down, left, or right. It's a slide. For example, if I had an object that looked like this, and it went and moved this way, then this way, it would still be pointing the same direction. It's supposed to be the same size shape. Try to make it the same size. That's a translation. A translation is a slide, either up, down, left, or right, and it can go right and down. It can do any combinations of those things. Same spot. When you do a translation, there's this thing called the pre-image. The pre-image is the original figure. So this is the pre-image. This is the one that it started with. It's called the pre-image. It's the original figure. And then after you translate something, like this is now the translation, this is called the image. Pre-image is before, image is after. A lot of times we use primes to let you know what the image is. I'll give you an example. I'll even zoom in here for you to see it. So for example, let's do this. Let's do RAP. If this is my triangle, RAP, and then I translate it to the right and I translate it down, this is my pre-image, RAP. The image would be R prime, A prime, P prime. These little apostrophes let you know that they are the second point, that these are the new image after the translation. We use primes to let you know that this is the second object. This is the one that has been moved, that has been slid somewhere else. Make sense? And so what you're going to have to do today is you're going to have to translate objects. And I'll give you an example. I'll give you an example like number 6. This is number 6. It's going to be a little bit difficult to draw, but let's do our best. Let's go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, you can barely even see that. So let me move that up a little bit. There we go. And -2, -2, 1, 2, 3. There's J. There's E. M. X. There's my object right there, JEMX. And your directions will say this on number 6. It will say, translate 2 units right and 3 units up. So what does this mean? This means that we're going to be taking this object that we have here and we need to translate every single point to the right 2 units and up 3 units. What does that mean? That means that I take this letter M and I'm going to move it to the right 2 and up 3. I'm going to take the X and move it to the right 2 and up 3. It means I take the E and move it to the right 2 and up 3. It means I take the J and move it to the right 2 and up 3. For example, let's take this J. The J right now is at -2, -3. -2, -3. This is where the J was, and I need to move it to the right 2, 1, 2, and up 3. 1, 2, 3. This spot right here is where my new J prime is. Thank you. Do you notice that when I move J to the right 2 and up 3, what did I label it as? I labeled it as J prime. What does that let you know? It lets you know that this is my original, this is my pre-image, and that this is my image. This is my new object. It's been translated. But I've only translated 1 point. What else do I have to translate? I have to translate the E. So the E is over at -2, -4, -2, -4, and I have to go to the right 2, 1, 2, and up 3, 1, 2, 3. So my new E is right here. E prime is this one right there. Do you know how to do the M prime and the K prime? If you do, go ahead and finish that. So what I'm hoping you got is something that looks very similar to mine, and you have J prime, M prime, X prime, E prime, and it's the same object. Look at how it kind of goes up and to the right and up and to the right. It's the same object. All that happened was that we slid it. Okay? So far, so good. Pretty simple stuff. That's what I thought. But we also have to know something called function or coordinate notation. Coordinate notation. What we just did was how we wrote out the translation in words. This is in words. Okay, like 2 units right and 3 units up. Coordinate notation, we can write in the fancy mathematical notation. Think of it like that. Okay, this is how we would write what we just did. This is an example of what we just did. The first thing we do for coordinate notation is we write x, y. Doesn't matter what the x is or what the y is. It's going to be translated where we do x, 2 units to the right means we're going to do x plus 2. And 3 units up means we're going to do comma y plus 3. What this means is that if I had an x-coordinate here, doesn't matter what the x-coordinate is, I have to add 2 to the x-coordinate and get a new x-coordinate that's going to be 2 units to the right. And the y-coordinate, we're going to add 3 to the y-coordinate and get where our new y-coordinate is going to be. And if I use this, it's the same thing as this. This is the same thing as this. This is in words. I'm going to put right here, this is in words. And this is in coordinate notation. This is like the mathematical notation of how we just did this previous problem. So if you see something like this in this notation, you should be able to do all the problems that we just tried right here. So the last example that we have is where you're going to have to describe the translation in coordinate notation. Here's the last example, and I'll do something like what's the easiest one to draw? Number 12 is the easiest one to draw for us. Number 12 looks like this. This is a fiver. 2, 3, 4, 5. 1, 2, 3, 4, 5. Down 1, 2, 3. And we have here to the right 3. 1, 2, 3, down 3. 1, 2, 3. To the right 1, down 1. The top is at 4. And it says T, P, B. Then it says T prime, P prime, B prime. Describe the translation in coordinate notation. That's what the directions are going to say. Describe the translation in coordinate notation. The hardest part for some of you is to know which one is your original object and which one is the moved object. So the original object is the one is the pre-image. Is it TPB or is it T prime B P prime B prime? Which one is the original object? This is our original object, the bottom one. And then we go to this image. So we're starting here, we're ending here. If you don't know, you can write start, end, it's fine. And what we're going to do to write this in coordinate notation is the very first thing we write is this part right here. We're going to take an XY coordinate. Got to have an X, comma, got to have a Y. No matter what our X and Y is, we are going to translate it using these coordinates. We're going to take these X, Y's and we're going to translate them. How much does our X move? Up 0. Or to the right 0. Don't forget X and Y. X deals with how many right and left it uses. So it's not moving anything right or left. And I'm going to write that off to the side here. X is left and right. Y is up and down. Just so that we're aware that X is like left and right and Y is up or down. When I look at T and T prime, they didn't move anything left and right. You could think of it as adding 0, you could think of it as subtracting 0, but if I do X plus 0, guess what that is? That's just X. The X is going to stay the same. You could think of it as X plus nothing, but that simplifies the X. And then, what about the Y value? What did we do? How far up did we go? I think it's 4, so I'm going to put Y plus 4 there. And that's the answer. That's all we have to do. If you want to check your answer, this is how I check it. I went up 1, 2, 3, 4 right there. Well, that should work for this part too. 1, 2, 3, 4. It does. Let's check for this one. 1, 2, 3, 4. If it's a translation, if it's a rigid motion, then every single point will go up by 4 and go 0 left and right for your X's. That's how it works. Pretty simple stuff. That's where we're going to stop your notes then.